Hey there. So, today we are going to be back in our MicroCraft level generator. Like I said last time, the goal is to rewrite the renderer for this game because it's too slow to really be functional in the mini micro. And the first step is making the level generator a little zippier than it is right now. The first level takes 3 seconds to load. Second level takes 7 seconds, and it just keeps getting slower from there. And I have a theory that we can make this a lot faster. The level generator, you can see the code back here. It was written, like I said, it was written over a weekend for a Ludum Dare competition. And it was written to run in Java. I think we can make this thing more efficient. There's a lot going on in here. I think we're just going to step through this one function at a time and see if we can optimize it. Start with some simple things here. So if you go to the level gen test, the first level takes 3 seconds to load to create and validate this, what's the top map that it starts with. And how long it takes to load that sky map. Go up one more level. That was pretty quickly, actually. It's interesting. So we're starting here. Create and validate sky map. So while loop, it creates the sky map, and then it makes sure that it has a certain number of tiles. It has to have at least 2,000 cloud tiles, at least 2 stairs. It's looping through the entire map, counting each type of tile. Everything's being ANDed, which feels unnecessary. I'm going to pull those out of the loop. It's just an extra function call that I don't think is gaining us anything. I'm not sure this generating the count array is gaining us anything. Let's see. It really depends on how you create the object. Because in MicroCraft, if I were to create a count array, I can't just treat it like a sparse array and throw stuff in there. But if I were to create an object, then I can. So what I think I'm going to do is that. Just change it to a map. And let's do that with all of our validate functions. Part of the optimization problem is figuring out what is the right data structure in this language to accomplish what you're trying to do. So the iron ore. Oh, okay. Iron ore ID plus depth -1. What that means, go to tiles, 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 no, we need the tile dictionary, which is actually defined. Where did I put that? There. As you go down, the type of ore is going to become, this ID is going to go up. So that's what it's testing right there. ID is 19 plus the depth. It basically increments down this list. As you go deeper into the caves, you should get higher level ore. And same thing here. The attempt variable is being created but not used. Let's put that in there right quick. Let's see if that might not have much of a significant difference, so we're just gonna take a look. Ah, key 2 not found in map, level gen line 87. I already thought that would work. Oh, it's because you can't add to it until you've created it. Oh. Fine. That makes sense. I'm just a little annoyed. Alright, did that have any effect? See how many times it's attempting to make the map? And that took 8 seconds. We have increased the time from 3 to 8 seconds. That is not what I meant to do. But is it actually because of what we did? Actually, it was taking 7 seconds to run last time. Today it was taking 3 seconds to run. There, now it's taking 3 seconds again. It's really a matter of how many attempts it's taking to build the thing. So, we need more metrics. I think what we're going to do, shove this thing full of profiling, just profilers. We need to know the time it's taking for all of this to complete. Excuse me. Okay. So, I believe the built-in function that we want is just called time. Yeah, time. It counts in seconds. And trying to think of the best way to do this. Hi minus start time. Seconds. And actually, I want to do it like this. Because we're going to be doing this all over the place, and I want it to be easy to read. So, let's start with attempt 0. It'll tell us what attempt number we're on, the current time, we need to augment this a bit, because I need to know exactly why the attempt is failing so that we can go and debug that elsewhere. Okay. And I don't need to print the total time on exit because we'll get that from the top level generator. Fill not found in map. I need a standard library import for just import all of the standard utility libraries. I'll put this in all my test files because otherwise I'm going to forget and have another bug later. Alright, we should now have access to the fill function. What do you think? One of the things that will give us is like which item is failing, and oh, we need to reset the start time if you want to know how long each attempt is taking, which I actually do. But it looks like each attempt is about 4 seconds now, but that's probably because of the profiling code. 2 attempts, each one failed to create the stairs down, and then after that it looks like it went through the loop 3 times. The 3rd time it got what it needed and stopped. The question is, why did it not create the stairs down? Fails if the stairs down count is less than 2. First time there are no stairs, the second time there's 1 stairs. This time it took 2 times to create the stairs. So what's up with the stairs? There's enough rocks and sand and grass, but not stairs. I'm going to disable the continue. I want to know what it looks like when there's not enough stairs going down. I'm seeing a lot less mountains, but it's enough. Try that again. It went through. This time I also failed to locate the stairs going down. And why? Why is there not this downstairs? So for the top map, width, I have several instances of this loop. Width times height divided by 100 minus 1. There's no minus 1 on the original, but kept it because it helped me replicate the exact range. I'm not sure the exact range is what matters here, though. In this case, it's scanning over a percentage of the map. The total area of the map divided by 100. And then that should pick a random spot in the map, ignoring the edges. We validate that the entire region is rock. And then we place the stairs down at that position if it's surrounded by rocks. Excuse me. So, scanning over the map, and we're scanning it multiple times, which is a little bit painful. So, like right up here, we have a similar loop, but this time we're placing cactus in sand. Grab a random spot on the map, any place on the map. Doesn't have, it can be an edge, but it probably won't be because the edges always seem to be water. And a useless check to see if the value is actually in range. This next int function is going to ensure that it's in range. And then if it's sand, we place cactus. We don't need that. We're doing the same thing here. This places flowers on grass. This one places trees on grass. Places sand on grass. This loops over the entire map, and then depending on the elevation, decides what to put there. Now, one thing that we could do, we have to loop over the entire map at some point to convert elevation levels into tiles. I just hate looping over the same data over and over and over and over. So anything less than negative 0.5 is water. Anything over 0.5 is rock. I'm not sure what M value stands for. Just a different kind of noise. We need to profile this also. Noise 1, M noise 2, M noise 3, noise 1, noise 2. That'll tell us, let's see, start time equals time. We'll reset the timer, and that will allow us to know how long each batch of noise is taking. And then we're going to do the same thing for these big loops. Loop 0, loop 1, guess what I'm going to call the next one? Loop 2, 3, 4, not R, 4, and 5. That should give us some useful information. Yeah, having that loop nested 3 levels in is painful. Gotta think of a better way to do that. Here it goes. So the noise maps are taking about a half second to complete. And the loops, that loop I was picking on about the stairs, is actually the easiest loop out of the bunch. The worst loop is loop 1, but even that doesn't compare with the time it's taking to generate the noise maps. So let's change the focus a little bit. Just want to take a look at loop, oh my, loop 1 has got 1, 2, 3, 4, 5 nested loops. That's not ideal. It converts grass into sand. Like this actually fills the region. There has to be a better way of doing that. Hold up. This is the worst of these loops, so we'll pick on this for a second and then we'll look at the noise function. So this looks at a percentage of the map. Kind of wonder if a different data structure would suit this better. I can almost imagine what I could use instead, but not really sure. We're picking a random spot on the map first. And then we're picking a random offset from that spot, plus or minus 10. And then, based off of that spot, we're picking another random offset. Plus, it's doing a random +5 minus a random +5. So, it could end up right back where it started. It could end up offset 5 to the left. It'll place a lot of stuff. I'm just, I don't know. We're going over a range. It's a 3x3 area centered on the XOYO origin. Make sure that that is on the map. And then convert grass into sand in that square. There's so many loops. Loop, 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 loop. I'm not sure what this is gaining us right here. The J loop. I'm going to try something and then maybe we'll know. Taking that 100, multiplying it by K. Oh no, let's just look at it. It places the sand a little bit differently, but it might be okay. Loop 1 is still half a second. It has these big areas of sand here. Were those big areas still in place when it was looking like that? The patch was a little bit smaller that time. Okay, and then check it out again. So if the only problem is that the desert is too big, then I immediately know that looks okay. What if we cut this in half? Loop 1 ran a lot faster, and the desert looks fine. This whole loop is about placing sand, patches of sand on the grass. What if I cut this in half? Loop 1 was still half a second. All right, let's take out the K loop. What effect does that have? Loop 1 was a lot faster. Ooh, but now I'm getting not enough sand area errors. 65 sand. All right, how much sand does it want? Split right. Sand. It wants at least 100 sand. Our error was that it's like between 40 and 60 sand. Want to double the sand, you double the loop. Still getting not enough sand. You know, I thought, oh, I changed it to 1400. When I double the loop, you need to like cut that in half, not double it. Okay. Yeah, watch my math. Okay, so you got these tiny patches of sand now. How did it get past the sand check? That does not look like nearly enough sand. Yeah, it's not going to work because it needs to, this XS and YS, that's the center of a desert region. And then it actually needs to look around the desert, which is what this is about. It's like, I think we might be able to leave the J loop out, but I'm not sure we can leave the K loop out. Oh, let me think. Oh, I just had an idea. We are actually going to chop that whole thing out. And I'll tell you why. We're going to try doing this a different way. I'm going to say if the val is greater than equal to 0.5 and val is less than or equal to 0, we're going to place sand right there. Let's see what that looks like. It might only put sand near the water. That's what it does. And that's kind of interesting. Makes it beaches instead of deserts. I wonder what inval will do with that. I really don't have a good handle on what inval does. So if we're at the beach, which is what that means, or inval is greater than 0. Oh, yeah, we're going to learn about inval. Disable the beaches. Just place sand where inval is greater than 0. That is looking better. Let's narrow this where inval is greater than 0.5. actually like the way this is going. Raise that a little bit more. That's too much. Let's do 0.55. Want it to look roughly like, yeah. We can do that and then re-enable our beach thingy. And can lower the beach just a little bit. Problem is that's too much. Is that too much? That might be too much. I just feel like there's a lot of sand everywhere now. Say 0.5 to negative 0.5 to negative 0.4. No. 0.3. We're going to get this right. Now I'll keep being OCD about my numbers until it is right. All right. So that saved us a half second. Just moving the sand check into this main body where it converts the elevations. Chop that out. And now I'm wondering about, let's see, loop 0 takes 0.3 seconds, loop 2 takes 0.2 seconds. Loop 2 is placing the trees. Loop 0, we're going to leave that alone for now. I wonder if we can do something with the trees like what we just did with the sand. So the validator wants at least 100 trees on the top overworld map. And the trees, we are looking at a percentage of the map, pick a random spot, and then pick another percentage. We're going to look around that region, around that spot, and then place random trees there. So it's making clumps of forest. It's very similar to the desert generator. Let's disable this and make sure the tree generator is just off. Make sure that it'll tell us if we don't have enough trees, and then it'll give us the map anyway. That's what that's for. All right, let's see what that looks like. It should be a world with no trees. There, one treeless world. I wonder what that black stuff is. Hold on, let's find out what that black stuff is. No, we'll come back around to it. I was hoping I can tell just by looking at this, but it's not really clear. We're going to use this to try to place trees based off the inval. That... Okay. I need to know what those black bits are. It's getting in my way. Gotta refactor this just a little bit so we can get a better idea of what is rendering. If it just falls through, we're going to color it pink, or light purple. Red, green, well, cloud cactus is purple. We'll just use red. If a red dot shows up on the overworld, we'll know something is wrong, because there's no lava in the overworld. Syntax error. See? It doesn't know what that is. Unknown tile ID plus map I want to know what is it trying to print. Threes and sevens. Okay, what are those? I think it's in items. 3 is a flower. 7 is a cactus. Okay. What was it using for grass? Kind of a green. Let's make a cactus a darker green. Red, green, blue. And a flower can be pink. Greenish pink. We'll leave that there just for error checking. Not enough trees. Okay, so the bright pink spots were, I think those were flowers? Yeah. And these black bits are the cactus, which I want to make them brighter. We have to be able to tell what's going on. Okay, now it's clear where the cactus are. I think that's water. Water in the desert, it's an oasis. Yeah. It's kind of neat with that circle there. Alright, now we're going to make another attempt at the tree placer. Just based off of whatever happens to be an inval, whatever that means. trees. It generated 25 trees. We need like 100 trees. So let's reduce the inval. Let's go to 0.4. Interesting how it clumps right around the deserts. Let's separate it from the desert by the val has to be greater than 0.1. Slightly higher elevation, not as high as the trees, as the rocks. Yeah, let's take that back. Let's look at negative inval. Still not really clear on what the inval is doing. Whoa. Too much. Say -1. Now the problem there, I don't know, I liked how the trees were all patchy before. Let's try some stuff. Well, no, that looks more reasonable to me. Let's make another. The clumping pattern is obviously different, but that might just be okay. I'm going to say that that's okay. Let's disable our profiling. Well, no, I want to, before we do that, let's look at the actual noise generator because it is taking way too long. I do feel like that should be an H. Alright, so we're spending about 2.5 seconds just making noise. Can we do better? Every time we make a sample, let's see, what breaks the while loop? When step size is less than 1. Every time it goes through the loop, it cuts the step size in half. When the step size gets too small, it stops. And then we have this sampler, which is pulling stuff out of the values array. It's pulling samples, setting samples. I don't think we need all these bit ends. I'm taking them out. We'll know pretty quick if that was a mistake. Just want to make sure that still works. Whoa! That was a mistake. Okay. Because of that half step problem. It was the y plus x and y might be in range, but if the half step is too big, you'll just step right off the map. Let me think. We ever do a subtract? No, it's only ever adding. Let's do a modulus. Okay. What does that look like? I felt like the noise generated a little bit faster. Was that my imagination? Looks like it's taken 0.4, on average 0.4 seconds instead of 0.5 seconds. Well, that's promising, but we gotta keep going. We're not done. What else can we do? This looks like it's just initializing the whole thing to random values ranging from -1 to 1. I created this random class just to mirror the Java class, but it's faster if we don't have to take a step into an extra class to pull a random number. Especially when you're doing it over and over and over and over. What else can we do? Set sample is just setting the values array at that offset to that value. And it is doing it by incrementing, like it's laying out a grid. I wonder if we can do this. Just collapse the array. Like that. That might do close enough to the same thing. It won't it'll get it right wrong, the noise right along the horizontal axis, but not the vertical. Let's see what effect it has on the final level though. Oh. -1. I'm saying that there's not enough rocks. It took 3 attempts to get the noise right. Let's do that again. It's not really saving much. It's not saving much, and I'm seeing more failures to create a good map on the first attempt. I don't know. That might just be that might just be a coincidence. I don't know. I'm seeing a lot more failures there. It didn't save anything. It's introducing bugs. Yeah. Okay. I mean, we can still cut out the middleman on this by inlining the function. Don't expect it'll save us too much. But we'll leave that. Alright, what are we doing down here? We got a step size, we have a scale mod. We break when step size is less than 1. The large feature size is going to take longer to generate than a smaller feature size. Is that what we see reflected here? First 3 have a feature size of 16. The final 2 have a feature size of 32. Do the final 2 noises take longer to generate? Not significantly. They're all about 0.4 seconds. So where are we losing the time here? I wonder what would happen if we merged those 2 loops. And I want that to be referring to the height for the y value. That looked a little bit faster. I'm seeing some 0.3s on our noise generator. That's always nice to see. What else can we do to make this speed up? It's getting into 0.3 sometimes, but not every time. I mean, just looking at the algorithm here, changing the feature size should make it go a lot faster. But how awful would that be for our final map? Whoa. That's kind of cool. All the features are smaller. Makes sense we said a smaller feature size. Didn't really affect the speed though. For each round through the loop, we are stepping over the entire map, incrementing by that feature size, focusing on smaller features on each round of the loop. We're going to set up a profiling thing here.
in so we know it's a different function. We're seeding the values after that first loop. And then we'll print out the step size and then how long each step size took. In each case, the final step size 1 took a lot longer than everything that came before. Can we clip it out? Disabling the profiler. Let's save step sizes less than or equal to 2. Then break. What does that do? It's probably going to leave dots all over our map. Yep. It's just that last one doesn't take twice as long, it takes a lot longer. Let's look at that again. Oh. When the step size is 1, it just iterates over the entire map. What's it doing with half steps? Now the problem, if the step size was 1, the half step is 0.5. And setting the sample at 0.5 isn't going to do anything. All the half step stuff doesn't happen until down here. So let's try this. We don't need to sample these unless that problem can be executed. That can go down there. All right, so in the final one, if the step size is 1, half step is 0.5, and then all of that will get skipped. That step size 1 still took a lot longer than the others. And also, that's basically causing it to do nothing if the half step. Hold on here. The last one, step size is 1. And then it breaks. Because if step size is 2, half step is 1, all that executes cuts the step size in half. Now step size is 1, step size is less or equal to 1, so it breaks. So really all that, like this does nothing. And really, we're measuring the step size up here. If we wait until down here, it's already calculated the next step size. So it's like, I don't care about that time. It's when step size is 2 that's taking, well, each one takes 4 times as long as what came before, which I guess kind of makes sense. There might not be a way around that one. We might need a different kind of noise generator. I'm going to pause our quest for right now. When we come back to this concept, I'll look at it. So Perlin noise is often used to solve this type of problem. When you're generating landscapes, and want to study up on this a little bit and then see if we can put a Perlin noise generator in place of whatever's going on here. I'm not sure what algorithm is being used here. It might be a Perlin noise generator for all I know, but I need to find out. There's fast ways of doing Perlin noise and there's slow ways of doing Perlin noise. So we are going to come back to this, and stick with me. We're going to figure this thing out. So that is all for today. See you later.